Welcome back. In the last video, we looked at reviewing how to label our triangles so that we can work with trigonometry. We have to label our hypotenuse first, and then figure out where we're standing, find our adjacent side and our opposite side. And we reviewed that that is important, or we discussed that that is important so that we can apply Sohcahtoa, the ratios for sine, cosine, and tangent, to triangles. Okay, so let's look at how that applies to triangles with actual numbers. Okay, so you see sine of angle A, cosine of angle A, tangent of angle B. And a lot of times you'll see it abbreviated just like this, but you still say the whole word, cosine of angle L, tangent of angle L. We don't say tan L, cos or cos L. And a lot of times you won't see that either, and it looks like sin angle L, but we still will say sine of angle A, cosine of angle A, tangent of angle A. Okay, so we want to find the sine, cosine, and tangent of the identified angle, and something that's going to be super important to always remember is we need to always reduce the ratio. Always reduce the ratio. So if you have 2/4, you should reduce that to 1/2, right? Okay, let's look at our examples. So the first one here, I want to find the sine, cosine, and tangent of angle A. The very first thing I said we always do is identify our hypotenuse. So in this case, my hypotenuse is 13. Then we figure out what angle we're standing at. Since I want the sine, cosine, and tangent all of angle A, that tells me that angle A is the angle where I'm standing. So this is where I'm going to put my smiley face, because that's where I'm standing. So now if I put my pen down at that smiley face and I highlight the side that's not the hypotenuse, I know that is the side I'm next to. So that's my adjacent side, and then all the way across is the opposite side. Okay, it's important that you do that because then we're going to remember Sohcahtoa, that's an H, because that's going to help us to remember our ratios. Okay, so my first ratio is O over H, opposite over hypotenuse. My opposite side is 5. My hypotenuse is 13. And then just look at that 5/13 to see if that reduces. If it does, you need to reduce it. This does not. There's nothing that goes into 5 that also goes into 13. So that fraction is my answer. I don't reduce it. I leave it exactly like this. Cosine A over H, adjacent over hypotenuse. My adjacent is 12. The hypotenuse is 13. So 12/13, nothing goes into 12, that also goes into 13, so that is completely reduced. My answer stays exactly like that. Toa, O over A, opposite over adjacent. My opposite is 5. My adjacent is 12. There's nothing that goes into both 5 and 12, so that is completely reduced. Those are my 3 ratios for the sine of angle A, the cosine of angle A, and the tangent of angle A. Okay, let's go look at the next one, where we're going to look for the sine, the cosine, and tangent of angle L. The very first thing we always do is find that right angle so that we can identify the hypotenuse. Okay, then we say, okay, we're looking for the sine of angle L. So then I go find angle L, and that is where I'm going to put my smiley face. That's important because that helps me find the adjacent, because I put my pen down and I highlight the side that's not the hypotenuse. That is my adjacent leg. And then opposite on the other side of the triangle, all the way across, that's super far away from my smiley face, is the opposite side. Okay, so now we're going to remember that we are doing Sohcahtoa, to remind us what our ratios are. So my first ratio is sine, opposite over hypotenuse. My opposite is 16. My hypotenuse is 20. Now both of those are divisible by 2, so I could say 8 over 10, but those are still going to both be reducible by 2 again. So remember, the bigger number you can find that goes in, the less you'll have to do reducing. So if I reduce both of these by 4, 4 goes into 16 4 times, and 4 goes into 20 5 times, and then 4/5, that can't be reduced, so 4/5 is my answer on this problem. Okay, make sure you reduce because you'll lose some credit if you give me an unreduced answer. Okay, cosine, adjacent over hypotenuse. The adjacent is 12. The hypotenuse is 20. And again, I can reduce both of those. I could reduce them by 12 or by 2 and say 12 divided in half is 6, 20 divided in half is 10, but then those are still also reducible again by 2 because they're still both even, which would be 3/5. And again, I could have said, oh, this is divisible by 4 and this is divisible by 4 and gotten immediately to my 3/5. Okay? The bigger number you find first, the less times you'll have to reduce. And then the last one, tangent of angle L, opposite over adjacent. My opposite is 16. My adjacent is 12. And we already saw that everything's divisible by 4 here. 4 goes into 16 4 times, and 4 goes into 12 3 times. Now, please leave your fractions as improper fractions. Do not change this into 1 1/3. Because then it's no longer a ratio. And these, when you look back up at what we're doing, these are trigonometric ratios. And remember, that is a fancy word for fraction that compares two values. So if you end up with a mixed number, you're no longer just comparing the two values. So you want to make sure that you reduce it, and if it's improper, that you leave it improper. Okay? And then last but not least, let's look at this last one. The very first thing we always do is find the hypotenuse. Then which angle are we standing at? Then we find our adjacent and our opposite. A really good thing to do right now would be to pause this video and see if you could do this one on your own, and then resume the video and see if you get the same answers that I get. Okay? All right, so hopefully you paused your video and now you're back with us, and we're going to look across the triangle at our hypotenuse. And then which angle am I standing at? I'm standing at angle J, so that's this angle right here. So here goes my smiley face, which means if I put my pen down there at J and I highlight the side that's not the hypotenuse, this 32 is my adjacent side next to my smiley face. And all the way across the triangle, really far away as I can get from that smiley face, is on the opposite side of the triangle, the opposite leg. Okay, then we're going to use our ratios, Sohcahtoa. Sohcahtoa. And we're going to make sure, if we can, we reduce our fractions. All right, so my sine is the opposite over the hypotenuse. The opposite is 24. And the hypotenuse is 40. Let's see. 4 goes into both of those. 4 goes into 24 6 times. 4 goes into 40 10 times. Oh, but those are still both even, so those can both be, 2 can go into both of those. 2 can go into 6 3 times, and 2 can go into 10 5 times. So if I noticed, I could have divided by 8, right? Because 3 times 8 makes my 24, and 5 times 8 makes my 40. But I still got there. 3/5 is my sine of angle J. Let's look at the cosine of angle J. Adjacent over hypotenuse. Adjacent is 32. Over hypotenuse is 40. And now I'm going to look at that 8 and see if 8 goes in, because now I know I've got a multiple of 8 here. 8 does go into 32. 8 goes into 32 4 times. And I know 8 goes into 40 5 times. So here is my ratio for cosine of angle J. Okay? And then last but not least, we need to do our tangent of angle J, the opposite over the adjacent. My opposite side is 24. And the adjacent side is 32. And I know that 8's going to go into both of these numbers. 8 goes into 24 3 times, and 8 goes into 32 4 times. So 3 over 4 is the tangent ratio for angle J. Okay, so the big takeaway from this section of the notes is going to be learning our acronym Sohcahtoa. This is going to be super important right here, is this acronym Sohcahtoa. I know it's a weird word, it sounds kind of funny to say, but it's a super important word when we're doing trigonometry. Tomorrow, we're going to find out how we use this information to find different side lengths and do things to find missing parts of the triangle. Okay, so come on back for that tomorrow. Today, make sure if you have questions, you ask during sync time and then get that assessment done. All right, thank you so much for watching.